Okay, solving systems of linear inequalities. That's a key word I want you to hear is the word inequalities, meaning that instead of the equal sign, you're going to have the greater than or less than or greater than or equal to, less than or equal to. So whenever you hear inequalities, that's what you need to think. We've been solving for a system by having two equations and we find out where they cross or whether they don't cross. That's how you've been solving it. So this is what you're going to do here, except for the fun thing with this is we graph it and shade it. So that's almost all of what we're doing. The solution to a system of linear inequalities, when it's like this, is an ordered pair that can fit in the graph, in the area. So I'll show you that. Look at example 1. We're going to graph the system of linear inequalities. So we have two inequalities. Y is greater than negative x minus 2. And then we have y is less than or equal to 3x plus 6. And we are going to graph, so if you want graph paper, there should be some over there, or you can just sketch it in your journals, whichever way you prefer. All right, I'm going to graph this first line in blue and the second line in red so you can see it really well. Now the nice thing with this first example is it's already in slope-intercept form. And you have to have the equation in slope-intercept form in order to graph it. So in your homework, if they give it to you if they give it to you in standard form or whatever, just solve for y so that way you can graph it. Tell me when you're ready and we'll do this one. Okay, so for this first equation, what is my slope, or my y-intercept? So I'm going to go down to 2 and put a dot. And then what's my slope? Right in front of the x. Negative 1. So I go down 1 over 1. Okay? And then we connect this. Now here's another key. If you look at the sign and it doesn't have an equal to underneath it, if it's just greater than or less than, then it's a dashed line. Because that's telling me that it does not include the line. So the solution to this linear equation does not include points on the line. It's saying it has to be greater than that line. Does that make sense? So then I do a little cheat right here and I go, okay, the last thing I look at is what's the sign saying? It's saying that y, the answer, is everything greater than this line. So I go, okay, so when I shade it, it's going to go above that line. So I'll draw a little arrow like that. Eventually you'll get to where you don't need the arrows. It'll make it fast. So that's the first line. So now let's do the second one. Thankfully, it's already in slope-intercept form. So what's my y-intercept?
6.
So I'm going to go up to 6 and put a dot. And then what's my slope?
3x.
3x. So you'd go up 3 over 1, right?
3 over 1.
I run out of room, so I'm actually going to go down 3, back 1. 1, 2, 3. Basically, I'm doing the reverse of it.
If we have enough space, can we do the...
Yeah, go up 3 over 1. It's easier to do it that way. Okay, and then the last thing I look at is the sign. Does it have an equal to underneath it?
Yes.
Yes, so I'm going to draw a solid line connecting these two dots. I almost connected the dots. And then I go, okay, y is less than this stuff or greater than this stuff? What does it say? Less than or greater than?
Less than.
So I know it's barely tilted, the line is, but it's going to be everything below that tilt, so it's going to be everything over here. Okay, and then you shade it. And you shade where the arrows are pointing in just that gap. So in this case, it's going to be everything.
It has to be perfectly shaded.
No, I don't care if it's perfect. Just don't cross the lines. Okay, and all that tells you is that the answer to this system of linear equations is somewhere in here. And it's going to be in the form of x comma y, in the form of a coordinate. Okay, sometimes they'll ask you, is, 1 comma negative 1 a solution? So then you just graph it and say, okay, 1 comma negative 1 would be right in here. Yes, that's a solution to the system. Because it's in the shading. Does that make sense?
Yeah.
All right. that's what we're doing. So let's go do another one. All right, so this is example 2. And this one we have 3 inequalities. We have y is greater than or equal to -1. We have x is greater than -2. And then we have x plus 2y is less than or equal to 4. So right away I know I gotta solve one of the equations, right? Because this one is in standard form. The other 2 I can graph. So let's solve this first one for y. I'm going to subtract x. So I get 2y equals -x plus 4. And then to get the y by itself, I divide by 2. So y is less than or equal to plus 2. All right, does that make sense?
Yes.
Undo. I'm trying to learn this little, it's a duplicate thing, but I can't write in a straight line, so it's not helping me. Hold on. There we go. And then I can grab that. Haha. And I want to do that because I want to erase this. Because I'm going to put my graph over there. You don't have to erase yours. All right, so go grab a graph. And we're going to graph it. We have to graph all 3 of these lines. All right, so I'm just going to graph them all in blue. So we have the first one, y is greater than or equal to a -1. So what kind of line is this one going to be? It's on the y line, right? Because we have y is great. So we're going to go down to -1 on the y line. That makes sense so far, right?
Yes.
-1, put a dot. And then what kind of line is this? I don't have a slope, do I?
No,
So it's a nice horizontal line. Is it solid or dashed?
no, it's solid.
Solid, because it's got the equal underneath.
Yeah.
All right, so we got our horizontal line. So now let's look at the next of the system of linear equations. We have x is greater than -2. So on the x line, I go where? To -2. And I put a dot. And then what kind of line do you think that one is?
Dot.
It's a dashed line, absolutely, because it's not equal to. And since it's on the x value, it's a vertical line. Like so. Oh, and I forgot to do my little arrows. The first line, y, is greater than that line, so we're shading everything above it. X, everything greater, so greater is technically to the right. Now let's graph our last line. So we have y is less than or equal to -1/2 x plus 2. Where does my first point go?
2.
+2. And then my slope is?
1/2.
Down 1 over 2, right?
Down 1.
So right there. Very good. And then is this a dashed line or a solid line? It's a solid line. And then is the shading going to be above that line or below that line?
That's going to be between those lines.
It's going to be below that one line because it's y is less than, right?
Yeah.
So I'm shading everything in this little teeny triangle. I guess it's not little teeny. This is often what happens, you guys, is you're shading in the middle of a shape. Very rarely would you ever shade out here and leave the triangle. So if you look at it and you feel like you're supposed to shade outside, check your work first, because very likely it's not right. Now, sometimes you'll have, like an open-ended thing, and you have to shade in that area kind of thing. It doesn't fill it in like a triangle. All right, any questions? Not too bad, right? Okay, so let's look at example 3. Write a system of linear equality. Oh, we're going to go in reverse. So, let me take this picture. All right, so we have a graph with lines on it already, and it says to write a system of linear inequalities for the shaded region. So we are going to create the lines. Okay, so looking at this graph, how many lines are there drawn on here? Not including the coordinate lines, of course.
2.
2, right? So we're going to find the equation for this line and then an equation for that line. Which one do we want to do first?
The easy one. Let's do
The horizontal one? That is the easy one. Let me erase this. It makes it hard to see it. Okay, so looking at the horizontal line, we know there's no slope, right?
Yeah.
So then you know it's just going to be y equals...
Y equals 3.
Look at that. Now, I messed up already because it's in an inequality. Hard for me to say. So what sign should go here?
It should be equal to.
It should be equal to, is it y greater than that line or less than the line?
Let's say greater.
Greater. So then it's actually the y is greater than or equal to because it's a solid line. Very good. So you got your first one.
Mm-hmm.
So now the other one is a diagonal line, so we definitely have a slope. So we're going to say y. Is it shaded above the line or below the line? I know it's kind of weird because it's at an angle, but what's your guess?
But I would say above the line.
Above it, yeah, because it's, even though we're at a tilt, it's above that line, if that makes sense.
Yeah.
So then is it greater than or equal to or just greater than?
It's just greater than.
Right, because it's the dash line.
Yeah.
So you're just going to say greater than. So then, now we need to find our slope and our y-intercept, right?
Mm-hmm. So say it's 1.
Well, what's our y-intercept? Yeah, +1, so I'm just going to write that over here on the right.
Plus 1.
And then going from this 1, here's another point, right? So I go up how many?
We go up 2 over 1.
All right, so that's a positive 2 over 1x.
2x plus 1.
So you just wrote 2 equations for a system of linear inequalities. Not too bad. I keep saying that. See, I told you I like this lesson. All right. Any questions? That's the lesson.
No.
That's it.
Kind of easy.
I think you can handle this. So you're doing numbers 3 through 33 odds. Make sure you show your work.